In my previous video, I have discussed, I have started classical mechanics problems. So, in my next video or now video, I will discuss another classical mechanics problems, all the classical mechanics problems that will be related to JEE, NET, or JEE exam, NET exam, NET, CSI or NET exam, and for all board exam also. So, the problem is two mass M1 and M2. They are having one have mass M, one has mass M1, another has mass M2. So they are placed on a frictionless surface. Now a horizontal force F is acting on the M1. So now what's the question? So two mass M1 and M2 are in contact and at a frictionless surface. So a horizontal force F is acting on the mass M1. Now I have to find the force of contact. Between M1 and M2. So let's start discussion. So for finding the contact force between M1 and M2, we have to draw first free body diagram. So let's start discussion of free body diagram. First, drawing of the box. Now I will draw here a horizontal force F. It is the mass M1. Okay, it is the mass M1. So a vertical force M1G is acting here. And a normal force R1 is opposite to it, R1, and another force from the small mass M2 will be here, So I have drawn the free body diagram for mass M1. For mass M1, the free body diagram is M1G is acting downwards, horizontal force is acting from here, and opposite normal force is acting and here, and the force due to this mass, normal force you can say, is acting from the right hand side of the mass M2. Now I will draw the force. I have to find the force of contact between M1 and M2. So only force acting on the combined system is F, and two bodies move with common acceleration. I will draw the free body diagram similarly for M2 masses also. For M2 masses, what's happening there? For M2 mass, I am drawing the force. It is the mass M2. For M2 mass, M2G is the gravitational force here acting downwards. Normal force R. And here N is the normal for this mass M1, due to this mass M1. So observe that the only force acting on this combined system, that is M1 M2, is only the force F. And after the force, the two bodies move with a common acceleration. Let it be A. The body moves with common acceleration. So we have to find the force of contact between M1 and M2. So getting the common acceleration, we have to write the equation of motion. Common acceleration, for common acceleration, equation of motion is F equals M1 plus M2 into A, where A is the common acceleration. Sorry guys. So where A is the common acceleration on the system. Now M2 mass also that means moves with acceleration a. So from here what we are getting, first give it mod sign, because f is vector quantity, so mod of f means what? Magnitude of the force and magnitude of the force equals m1 plus m2 into a. So from here what we will get? From here we will get a equals, take the magnitude of the acceleration, f by m1 plus m2. It's easy now, because it is common acceleration, so equals f by m1 plus m2. So I have to find what? Always mind it that I have to find the force of contact between m1 and m2. So as common acceleration is a1, that means m2 mass is also moves with acceleration what? A. So for m2 mass, if moves with a common acceleration a, then the force acting on the m2 mass will be what? Force acting on the m2 mass will be m2a. And for a, what we have got? A equals f by m1 plus m2. We have got na. So what is the force? It is a force on m2. So it is a force on m2 that is acting on m2. So this is the force of contact between m1 and m2. So this is the answer. So what we got, I am telling you a gist. For finding the force of contact between two masses m1 and m2, we have found that they have both common acceleration a. F equals m1 plus m2 into a. So from that we have got the a equals a value for both combined motion. A equals f by m1 plus m2, as the common acceleration is a, because only force is here f. Acting, external force is acting on the combat system is what? F. So from there we have got f prime, let it be f prime, m2a equals m2f by m1 plus m2. M2a, why we have taken for the acceleration of m2 is also a, because it is a common acceleration now. So for common acceleration, a equals f by m1 plus m2, so f prime equals m2f by m1 plus m2. So let's discuss third problem. So third problem, I will discuss very interesting problem, similar type of problem. If before this problem that I have discussed, the mass was along with them, but now the mass is a small mass m here, and another small mass, another mass capital M is here, here small mass small m. So consider the system of the third question. So what is the question? Of mass small m to system of mass, one block is capital M, another block is small m. The system is started with so this system started with velocity u. Coefficient of friction between, so here the coefficient of friction between m1 and m2, m and small m, is mu. Coefficient of friction, let me change the color of the pen so that you will understand here. You will understand here. So the coefficient of the friction between this contact surface is mu, and the system is moving with velocity u, and that of coefficient of friction, it is mu by 2, and here surface and capital mass m is mu. So what's the question? One mass is capital M, another mass is small m on the capital mass on the big mass m. So two mass of blocks m and small m. Coefficient of friction between capital M and the horizontal surface is mu, and coefficient of friction between capital M and small m is mu by 2. So I have to find what? I have to find the time taken for the block M, to separate from this M, capital M. That means here I have to calculate. That means the problem is saying that this is the system of two blocks, capital M and small m, and the system is started with velocity u towards right. The system started moving u with velocity. System started moving with velocity u towards the right, and the coefficient of friction between horizontal surface and the mass m is mu, and mass m and small m, the coefficient of friction is mu by 2. So what we have to find? We have to find that the time taken for the small mass m to separate from capital mass m. Hope you understand the question. Question is time taken for the small mass m to separate from the capital mass m, capital M. So let's start the problem. Let's start solving the problem. So in this case, initially capital M, and let me change the pen color. In this case, initially capital M and small m must tend to move together. So initially no frictional force, let it be small f. So initially no frictional force appears, and m slowed down, and when the capital M mass, that is here it is small m, capital M mass moves slowing down due to its contact frictional surface, because if capital M moves rightwards, then the frictional force is opposite to the force. This is the force due to the movement of capital M mass with velocity u, and this is the frictional force small f that will act backward, that is opposite to the capital F force. So that's why capital M mass is moving slowly. That and frictional force also, if small f appears, frictional force small f appears between capital M and small m. That is, here it will be also frictional force now, because when two masses are in contact, then the friction force appears between them also. So between capital M and small m, there will exist a frictional force small f. So these act backwards on m. So these will also act here. Let me draw cleanly. First, let me change the pen color. So this is the capital M mass, capital M and small m mass. So frictional force, when the capital M mass moves here F, frictional force will move, frictional force will act here also, and here also a frictional surface. So when it will also move here, so frictional force small f is also acting backwards the external force, opposite to the external force, and this frictional force small m backwards the m, but this frictional force small m will forwarding the capital M. Yes, this is very interesting. The frictional force between capital M and small m will be acting backward the motion of small m, but will be forwarding the capital M mass. Yeah, you will get it very clearly when I will draw the free body diagram. So let's drawing the free body diagram. Free body diagram is very important for any problem solving. So here free body diagram for capital M mass, and here free body diagram for small m mass. Okay, as well as here gravitational force mg and normal force n, frictional force F, and as well as here small mg, normal force N, frictional force, let it be F prime. But this frictional force, now if I replace this here, now if I am going to draw the but before that, this frictional force F prime is acting on backward to the small m, but it will act forwarding to the capital M, because you will see when you have placed a big box and above that big box, if you have placed a small box, the friction force due to the contact between capital M and small m will backward the small box, but it will forwarding the forwarding the big box. So due to this mg, this is a gravitational force, the normal force will be act perpendicular to it. Okay, no problem. And now I am writing the all parameter here. This is very important. For small mass m, here the small mass m, mg, here n, and friction force F prime equals what? Mu into n. That means what? N is equal, and this is the normal force. This is the normal. And normal is always what? Equal and opposite to the mg. That is N equals mg. So frictional force equals what? F equals mu, here mu by 2n. Mu by 2n. Let me write, because in the question it is given the frictional force between capital M and small m is mu by 2n. So for small m mass, frictional force is mu by 2 mg. Mu by 2 mg, because n equals what? Mg. So what we have got here, we have two mass, capital M and small m, and both are the combined system. Frictional force between capital M and small m is F prime, and the friction coefficient is mu by 2 between capital M and small m, but mu between capital M and horizontal surface. So let's write the parameter for capital M mass also. For capital M mass, the mg is acting here, capital mg, but normal is always here n prime, but you have also small mass here also. So due to this, a normal force N will act extra here. So what can we write this normal force? These because N equals small mg now we have got. So this force also downward, this force small mg is also acting downwards on the capital M mass. So this normal will be what? It is very essential, because these are capital mg. But over here small m mass is also there, and gravitational force due to the small m mass is what? Small mg, and small mg is what? Capital N, normal force. So normal force due to the capital M mass will be what also? Normal force due to the capital M mass will be N prime. Oh, sorry. N prime equals N plus mg, and F prime so frictional force on the capital M mass will be what? Mu into n prime, and mu into n prime means what? Mu into n plus mg, mu into n plus mg. And m plus mg. N means what? N means will be capital Mg. So n prime can be written as can be written f prime equals mu into n prime n into m plus capital Mg. So because here you see, let me make you understand properly. Because F prime is the frictional force appears between m and small m. This F prime is the friction force appears between F and small m, and n prime is what? N plus mg. So F prime will be what? Mu into small m plus capital M to g. So here, sorry, this capital M will not be here. Mu into n prime equals, we have got n plus mg, and n equals what? Small mg plus capital Mg. So now we will write the acceleration, because it's always very much important to write acceleration. Acceleration of what? Capital M mass due to the effect of all forces. So how we can write the acceleration? This is very big question. How we can write the acceleration? So let me draw, or let me write clearly over here. So on the capital M mass, what we have to find? We have to find the time where small m mass will depart from capital M mass, will separate from capital M mass for that time. So here capital M mass, frictional force F is acting here, and F prime is acting over here. So acceleration will be what? Acceleration will be F minus F prime divided by capital M. Acceleration will be F minus F prime divided by capital M. Yes, because for separating the mass m to capital small m, we have to overcome this. We have to gain this acceleration. This is the forwarding frictional force F prime. This is the backwarding frictional force F. So F minus F prime equals m. So let's write the mathematical expression of this. A equals F minus F prime divided by m. So F minus F prime equals what? Minus mu by 2 mg, minus mu by 2 mg plus mu small mg capital Mg plus small mg whole divided by capital M. Let me write clearly. So acceleration equals F prime minus F by capital M. So minus mu by 2 small mg plus plus mu into capital Mg plus small mg whole divided by capital M. So now it is more natural to analyze the motion of small mass m in the frame of capital M. That means now we will draw. So let it be first simplify it. Before that, it will be mu g plus mu by 2 small m by capital M into g. This is the acceleration. This is the acceleration of capital M mass. So it is more natural to analyze the motion of small m in the frame of capital M. We will draw the free body diagram of small m mass. Free body diagram of small m mass in the frame of capital M. So now drawing the free body diagram. Free body diagram here, it will be small mg. Here it will be normal force N. Here it will be small ma. And friction force is F prime. So here it is for what? Small m mass m. Small mass m. So here what will be the acceleration of the small m mass in the frame of capital M mass? So in the frame of capital M mass, acceleration of small m mass, let it be A prime. Yeah, let us denote is M prime. A is the acceleration of capital M mass, and in the frame of small m, in the frame of capital M mass, the acceleration of small m mass will be A minus F prime by M. And what we have got A? We have got A equals mu g plus mu by 2 mu g by mu by 2 small m by, we have got A equals mu g plus mu by 2 small m. Let me write properly. Small m by capital M into g. We have got this acceleration of the capital M mass. So put this acceleration value here, and F prime equals what? F prime equals mu by 2 mg, because here acceleration is, because here frictional coefficient is mu by 2. So for F prime equals mu by 2 mg, so put this A value here, you will get F prime equals let me write, you will get F prime equals A prime equals let me write, A prime is the acceleration of small mass. A prime equals mu g by 2 plus mu by 2 small m by capital M into g. This much of acceleration we have got. This is the acceleration for small m mass, small mass m. Now what will be the acceleration, what will be the time, what will be the time for the mass small m to separate from capital M? So now for the time, we have to check one thing here. This is small mass m, this capital M, this small mass m. Let the distance is small l. Yeah, let the distance is small l. Now we have to find the time taken by the small mass m to overcome this distance will be, there is a formula, root over 2l by A prime. A prime is the acceleration. A prime is the acceleration of the small mass m. You will get the kinematics. You will get from the kinematics. As equals ut plus half ft square of v equals ut u minus ft. From that such kinematics, you will get t equals value root 2l by A prime. So now we have to put A prime value here. a prime value what we have got. So if I put the a prime value, t equals root 12 by a prime, then we will get root 12 by mu g by 2, and after taking the common mu and g, 1 plus small m by capital M. So we will get 4 lm by mu g into capital M plus small m. This is the t value. So this much of time will be required for the small mass m to separate from the capital M mass m. For the time being, thank you.